Alright, so here we are with Unit 1, Lesson 3, and what we're going to look at in this section is we've already looked at the properties of matter, we've looked at physical and chemical changes of matter. What we're going to look at next really has to do only with mixtures and how you separate the components of a mixture. If you remember back, we said that there are two kinds of mixtures. There are heterogeneous mixtures and there are homogeneous mixtures. And we're going to look at a few different ways of separating a mixture. They don't all work with each type of mixture. For example, some work with heterogeneous, others work with only homogeneous mixtures. So we're going to look at a few of them right now. The most common one that we do in class, and we'll do a lab on this, is using the process known as filtration to separate the components of a mixture. It is a physical type of separation. It involves no chemical reactions. And generally speaking, filtration is used when you are filtering a heterogeneous mixture. For example, if you mix sand and water and for some reason you wanted to then separate the two components again, you take that, you run it through a filter, which is basically a similar piece of paper to coffee filter. The water, because the water molecules are small, would go through the filter, but the sand particles, because they're too big, would get stuck in the filter, and you would separate out the sand from the sand from the water. And as a matter of fact, the liquid that drips into the beaker is called the filtrate. But this only works on heterogeneous mixtures like sand and water. Next would be evaporation, and you can evaporate in a couple of different ways. This would also work for a heterogeneous mixture like sand and water. It makes more sense to filter it, but you could use evaporation. So if you had a beaker with water and sand, you could just let the water evaporate over a period of days, and you would then separate the sand from the water. If you wanted to do it quicker, then you would heat the solution, the mixture, and separate it out. So this would work with both homogeneous and heterogeneous, but it's usually used for homogeneous mixtures or solutions. So for example, if I took water and dissolved salt in it, you could try using filtration. The problem is that the salt, of course, because you dissolve it in the water, the particles of salt are so small, they also will fit through the filter. So what would happen is, well, nothing. You would pour the water and the salt through the filter, and both would go right through it. There wouldn't be anything trapped in it. What you could do is to use evaporation, is to heat the salt water. The water would evaporate, leaving the salt in the dish. And you could use a watch glass. You could put the liquid on top of the watch glass and heat it. You could just heat a beaker with the solution in it. You could use a crucible. A bunch of different ways of doing it. A couple of less common things are, one is called distillation. Distillation is generally used when you are trying to separate a homogeneous mixture which is composed of two or more liquids. And how does that work? Well, it works because when you put two liquids, they have to have significantly different boiling points. For example, if I wanted to make a mixture of water and alcohol, they are both clear solute liquids. It's hard to tell them apart. But they do have very different boiling points. For example, pure water, boils at approximately 100 degrees Celsius. Alcohols tend to boil at about 79 to 80 degrees. So basically what you do is, in this case they're doing salt water, but if you wanted to do those two liquids, you put the alcohol and water in this container, you would heat it. The temperature would rise. Once the temperature reaches approximately 80 degrees, the alcohol part of the liquid of the solution would begin to boil. The alcohol turns into a gas, vapor. It travels down this tube where it is being cooled by running water. So basically the alcohol vapor runs through a small tube canal in the middle, and it's surrounded by cold water. That condenses it back into a liquid. Once all the alcohol, as long as the temperature doesn't get close to the boiling point of water, you will have evaporated all of the alcohol. That's a process known as distillation. We will talk more about distillation when we get to the unit on organic chemistry. We will do a lab on chromatography. Chromatography is generally used to separate the components of a homogeneous mixture also. What we will do is we will use different inks, and using the process of chromatography, we will separate out those inks into different colors. For example, black ink is not black. It has a bunch of different components to it. And you'll see that when we do the chromatography, it's actually pretty cool. So those are different ways to separate the components of a mixture. We're not going to worry about that. All right, so that is